right now I want us to do the change in momentum. So what exactly is a change in momentum? Well, when the momentum of the object changes from one direction to another, we call it a change in momentum. Well, a change in momentum can occur in a straight line where the object was moving to the right, after sometimes it started moving to the left, or it was moving to the left, after some time it was moving to the right. So we call it a change in momentum. So how do we calculate the change in momentum? So to calculate the change in momentum, this triangle here represents the change, and this P here represents the momentum. So is change in momentum is equals to the final momentum minus the initial momentum. So if I was going to the right, that means I have an initial momentum, and when I turn back to the left, I have a final momentum. So I'm going to take my final momentum and minus my initial momentum to get my change in momentum. So we can represent this symbolically. Let me show you this formula in your formula sheet. Let me look for it. So the change in momentum, well, it is here. The change in momentum is the final momentum minus the initial momentum. This is the formula that we will use to calculate the change in momentum. So without delaying any further, we can say there is P final minus P initial. We know that P is mv, so we can replace P by mv. We can say mv final minus mv initial, but we know that m is a common factor in both, so we can factor out the m to bring us this equation here. It is m into vf minus vi. Remember that vf minus vi is change in velocity. So our equation of change in momentum is mass times change in velocity. So like I always do, I like to do exercises first before I go into the exam stuffs. So I want us to do 3 exercises so that we can understand how the change in momentum works. But trust me, this weight here, it matters the most. This weight, I'm gonna write it in capital letters. Direction. Guys, direction is very, very, very important in physics. Once you mess up your direction, physics will mess you up. So I don't want physics to mess you up. So let's try to practice on how to master directions. When I choose to the right as my positive direction, that means everything going to the left is negative. If I choose going to the left as positive, that means everything going to the right is negative. If I choose going up as positive, that means anything going down is negative. And if I choose downwards as my positive direction, that means anything going upwards is negative. So once you understand how to choose direction, I'm telling you, this momentum thing is like a piece of cake to you. So let's do 3 activities and try to understand what is going on here. So let me remove this here. It's gonna disturb me. And I'm gonna do the solutions over this side here. I'm gonna read here and do the answering on this side here. So I'm gonna say 2.1. It says here, a ball of mass 0.2 kg is moving at a velocity of 7 meters per second to the right. That means to the right. And after some time, it has a velocity of 50 meters per second to the right. So it was initially moving to the right, and as it moving to the right, it gains some velocity. Still moving to the right, remember. And calculate the change in momentum of the body, or of the ball rather, not body. Calculate the change in momentum of the ball. So this momentum was moving to the right at 7 meters per second. It is busy moving to the right, it gains velocity from 7 meters per second to 15 meters per second. So how much did momentum change here? So to calculate the change in momentum, we're gonna say the change in momentum, I showed you the formula there, is mass into a final velocity minus initial velocity. So I'm going to choose to the right as my positive direction. So anything going to the left is negative. So they told us the mass of this object here, this is, where is it? Oh, 0,2. So I'm going to say 0,2 into, what is the final velocity? Well, it is 15 meters per second to the right. So it's a positive 15. And what else? Minus the initial velocity, minus, what was the initial value of 7 meters per second, minus 7 meters per second. I get an answer of, let me do it here, 0,2 into 15 minus 7. I get an answer of 1.6 kg per meter per second. And since momentum is a vector quantity, we say to the right. So when the ball gains a velocity, changes its velocity from 7 meters per second to 15 meters per second, it has a change of momentum of 1.6 kg per meter per second. So that is how you answer number 1. So let's do number 2 here. 2.2, and they say a tracker of mass 3 kg moves to the right with a velocity of 50 meters per second, and it then moves to the left with a velocity of 7 meters per second. Calculate the change in momentum of this tracker here. So what is happening here is that this tracker was moving to the right initially. It was moving to the right with a velocity of 15 meters per second. So after some time, it turns to the left. So it turns to the left and with a velocity of 7 meters per second. Calculate the change in momentum. So I'm going to choose a positive direction. Let me say I choose to the left. This time around, I'm going to choose to the left as positive. So anything going to the right is negative. So the change in momentum is equals to mass times the velocity final minus velocity initial. So it's equals to, the mass is 3 kg there. The final velocity is 7 here. So it's positive 7 because I choose to the left as positive, and this tracker is moving to the left also. So I'm going to say minus. But initial velocity was 15 meters per second to the right. So anything to the right is negative. So I'm going to say 7 minus negative 15, like this here. Do not mess up this direction. So it's 3 into 7 minus negative 15. So I get a momentum of 66 kg per meter per second to the left, because I choose to the left as positive, to the left, like this here. And what if you choose to the right as positive? Well, things I'm going to change here. So let me do it again. So here I'm going to choose to the right as positive. So what you're going to do is you're going to say change in momentum is mass velocity final minus velocity initial. Remember that mass is 3 kg. We cannot say negative 3 kg because mass is a scalar quantity. It does not have direction. So velocity final is 7. Remember, it's 7 meters per second to the left, and I choose to the right as positive. So it's minus 7 minus the initial velocity was 15 meters per second. So since I choose to the right as positive, I'm gonna write positive 15 here. And then you will get a change in momentum of negative 66 kilograms per meter per second. This negative here does not tell you that this momentum is less. It tells you that the momentum is in another direction. So you cannot say negative 66 kg per meters per second and leave your answer like that. No, you must say 66 kg per meter per second to the left, like this here, to the left. And like I told you, this negative does not mean in physics, this negative does not mean this momentum is less. It means that it is in another direction. I hope you grab that there. And let's do the last one here. 2.3. If you do not understand, you are free to ask anything. And number 3 here says a car of mass 500 kg is moving east with a velocity of 25 meters per second. It then turns north with a velocity of 30 meters per second. Calculate the change in momentum of this car here. So this car here was, let me answer here, it was moving to the east and then it turns north. So it was moving to the east with a velocity of 25 and it was moving to the north with a velocity of 30 meters per second. So the change in velocity, you can see that this is a right angle. So the change in velocity will be this way here. So for us to get the change in momentum, we will do the Pythagoras Theorem. I know you know it. It's h squared is equals to x squared plus y squared. Some use r squared, but it is fine. And what we're gonna do here is we're gonna find the change in velocity. After finding the change in velocity, we will use this formula here. The change in momentum, and let me move this here. So the change in momentum is equals to mass times the change in velocity. So let's find the change in velocity first. So the change in velocity, I'm gonna replace h with the change in velocity squared is equals to the velocity in the x direction. Velocity in the x direction squared plus the velocity in the y direction squared. This is the y direction, this is the x direction here. Hey, I'm gonna substitute here. So velocity in the x direction is 25. So it's 25 squared plus velocity in the y direction is 30 squared. So we're gonna take the square root of this here. So we're gonna say the square root of 25 squared plus 30 squared. So your answer is 39,05. Change in velocity is 39,05. Since velocity is measured in meters per second. So, and sometimes they might ask you to find the direction of the change in velocity. So if you want to find the direction, you just see the inverse tangent of the velocity in the y direction is 30 and the velocity in the x direction is 25. So your direction will be 50,19 degrees. This will be 50 50,19 degrees anti-clockwise. So but here we are not interested in the direction of the final velocity, but we are interested in the change in momentum. So to answer this question, we have the mass here is what is the mass? 500 kg. It's 500 kg, and then the velocity here is 39,05. The change in velocity rather. So we get a value of, let's say, 500 times 39.05, 19,525 kg per meter per second. So this is your change in momentum. What we did here, let me recap very fast. This car here was initially moving to the right here, and then it turns to the north. And for us to find the change in velocity, we have to use the Pythagoras Theorem, which is the hypotenuse. We want the hypotenuse side here. So we got the hypotenuse to be 39,05, which gave us the change in velocity. We know that the formula of the change in momentum is mass times the change in velocity. So we got the change in velocity here. So we just say the mass of 500 kg times the change in velocity. It gives us this change in momentum here. So I guess this video was helpful. Recommend to your friends, your classmates, and everyone you know that is doing physics in high school. So I will see you in the next videos where we will talk about the Newton's law in terms of momentum, and then from there we will be doing the vector diagrams. I guess I will see you in the next videos. Cheers.